everyone, welcome to Activity 8, Lesson 8.1 is going to talk all about slopes of lines and kind of our introduction. Now, this lesson is going to use a supplemental notes handout that is attached on Google Classroom that you could print out or just have a notebook or some paper ready to write your notes down on. Okay, you'll also want a pencil and possibly a calculator to help you with some of the addition and subtraction. Okay. Now, here we have just some key concepts and vocabulary. We talked a lot about slope at the beginning of the year, but just to kind of dust off some cobwebs that may or may not be formed over the past couple of weeks. Slope is our rise over our run if we're looking at a graph. It's how much a line is increasing or decreasing by each time. And again, it's the rise over the run. Sometimes we call that the change in y over the change in x. The little triangle just means change. Or a lot of times what you'll see, the slope formula, is you're going to subtract your your y values, the rise, over your subtracted x values, the run. Okay. Now, you do not want your denominator to equal 0. So that's why we say that they can't be equal to each other, because if your denominator equals 0, then we call that undefined, right? Undefined slope, because you can't have division by 0. Otherwise, it's undefined. Now, speaking of undefined, horizontal lines are lines that go side to side, right? Their slope is 0. They're not rising at all. They're only running. As to where vertical lines, so lines that go straight up and down, those are our slope. They're the ones that are only rising and not running at all, aka they have division by 0. So that's where the undefined comes in. So the vertical lines and the horizontal lines, they're kind of special in what their slope is. So just something to kind of know. And they're also going to always be perpendicular to each other, because if they intersected, they would form the right angles. Now, I'm going to bring back up our pal, Mr. Slope Man, at this time. So remember, decreasing is negative slope. Increasing lines are positive slope. Those vertical lines we just said are undefined slope. So look how he kind of has like a little U for his nose. And then horizontal lines have 0 slope. And that's Mr. Slope Man. Just as a way to kind of remember the special cases of slope. Now, when you have your slope formula, you always want to make sure you reduce it as much as possible. Otherwise, you might lose points. So let's say your slope, you rose 30 and you ran 20. Well, you'd want to make sure you reduce this to be 3 over 2. And on your calculators, if you have a graphic calculator especially, but even if you just have a smaller calculator, one way you can do this is by hitting the math fraction button. So for instance, on that example I just showed you, 30 divided by 20, if I hit math and then option 1 fraction, it'll reduce my slope for me, okay? If you're on a smaller calculator, you'll have to kind of hit it's the ABC button to be able to make sure that you get that reduced fraction, okay? Now, parallel lines. All right, we've talked a lot about parallel lines the past couple of weeks. Remember, parallel lines are going to increase or are going to go on forever, and they're never ever going to intersect, right? They have these little check marks. The reasons they're never going to intersect is because they have the same slope. Okay, so we would call that the same slope, and because they're rising and they're running the same amount each time. Perpendicular lines, on the other hand, have opposite reciprocal slopes. So for instance, here's an example of perpendicular lines, and we know they create that right angle. They're going to have opposite reciprocal slope, aka if we multiplied them, their slopes would be -1. I like to say you flip the sign and the fraction, because then they are going to be opposite reciprocal. So for example, on this one, let's say we have 2 over 7, then the opposite reciprocal of that is going to be -7 over 2. And again, you can always check, are these in fact opposite reciprocals? If we take 2 7s times -7 over 2, we get -1. So we can always double check if they're opposite reciprocals using our calculator. Let's say I just had 2 7s and maybe we had the positive 7/2. We wouldn't get the right answer here, so we know that they're not opposite reciprocals. We'll have to get -1. Now, actually calculating slope then, we've done this since the beginning of the year, but it's been a little bit of time. So a reminder, when you're calculating the slope, you want to make sure you take your y values and you're going to subtract them. And you're going to then take your x values and subtract those. So our x values are -3 and -1. Our y values are 7 and -1. So we start plugging this in. We have our two y values. And then remember, it's minus and always. And then in this case, our y value is negative. So minus -1. And then we've got to subtract our two x values, which were -3 and -1. Okay. I like to go left to right. As make these like my x1, y1, or you call them x2, y2. Doesn't matter. Now, when we simplify, reminder that when you have minus and negative here, it really turns into addition. So 7 plus 1. And then same thing down here, -3 plus 1, because that minus and negative really is addition. So we end up with 8 over -2 for a final slope of -4, or you could call it -4 over 1. Okay. Now, for example 2, we also want to calculate the slope here of C to D. So if we again take double lines, we'll see it, slope here. So we're going to take our two x values and subtract those. Oops. X and x. And then we have y and y. So I'm going to take my two y values. This time it's 5 and 6. We're going to subtract those. And then we're going to take our two x values, -3 and then 1, subtract those. So this time we end up with 5 minus 6 is -1. -3 minus 1 is -4. So positive 1/4 there. All right. The next two, or excuse me. Now what you want to notice here is notice our two slopes, right? If I asked you what is the relationship between the slope of AB and the slope of CD, you would say these are perpendicular because -4 and positive 1/4, if we multiply them, they're opposite reciprocals of each other. We have -4 times 1/4. That's going to give us a value of -1. Okay, so these would be considered, if I'd asked what kind of relationship, you would say they are perpendicular. Okay. Let's try another one. So we have slopes here of GH. So again, we're going to look at our two x values and our two y values. And a reminder, we're going to subtract the y values first. So 2 minus -5. And then we're going to subtract the two x values. So x is 6 minus -2. Again, when we subtract a negative, it really turns into addition. So both of these will come together to become addition. And we end up with 7/8, right, is our slope of this line. Now, if they're asking you for the slope of a line parallel to GH, we know from up above that that means it's going to be the same slope. So we're going to take a line parallel, would have to have that exact same slope of 7/8, while a line perpendicular has to flip the sign, so go from positive to negative, and flip the fraction. So 8/7. All right, last example for today, we have two lines that are parallel. or excuse me, two lines that are either going to be parallel, perpendicular, or neither, and we need to figure out what they are. So let's look at the first line, and that's going to be for AB. And if we find the slope of this, okay, again with AB, we're going to take our two x values and our two y values and subtract them. So negative 5 minus 7 for the subtracted y values, negative 2 minus 4 for the subtracted x values, negative 5 minus 7 is negative 12, negative 2 minus 4 more is negative 6, and the two negatives will cancel, and we will be left with positive 2 over 1, or just 2. Now, we also will need to find the slope of line CD to be able to see what's going on with C and D. So we have our two x's and our two y's. And if we subtract the two y values, 2 minus negative 2, subtract the two x values, 0 minus 8. So a reminder, minus a negative turns into addition. So you end up with 4 over negative 8, or negative 1 half. Okay. So we want to test, is 2, or 2 over 1, and negative 1 half. What do we think about the relationship here? Well, they're definitely not the same thing, so they're not parallel. And if we test it out, the signs are opposite and the fractions are flipped. And again, we can always use our calculator to guarantee it, but negative 1 half times positive 2 is in fact negative 1. So what we're going to see is that these are our slopes to a negative 1 half, and these lines are going to be perpendicular. Had they not multiplied to be negative 1 and they weren't the same, then we would have said this is a neither situation. All right, we're going to work more with slope in the coming days. Thanks, everybody. See you in class.